Hello guys, how are you? Welcome to my tutorial. In the last two tutorials, I will present the highlight or the introduction for CATIA software, how to draw a parts using CATIA software. In this tutorial, for now, I'm going to show you how to design a spare gear using standard parameters of the gear, and I'm going to show you how to make a perfect and precise gear using a CATIA software like this manner. This is a gear, spare gear parallel. There are 25 number of teeth, and all parameters of the gear are applied to do this. እዚህ ይሄ ጊር እንዴት እንደተሰራ መከታተል ትችላላችሁ ማለት ነው። This is a mechanical gear or spare gear. How to do this with easy way and perfect way. Look, everything are tooth profiles and so on. Very good how to do this and how to do by yourself on your CATIA software. We don't know, very important tutorial now. Just follow along. Let's switch this. Click start and click mechanical design. Click on part design, and you can write this part name spare gear parameters or spare gear. Spare gear parametric design. Parametric, click OK. Now I'm going to use the parametric. Click on the formula which is here, the title bar, FX. Here is the formula for spare gear parametric is present, and I can now import all parameters of the spare gear. Click here, new parametric type. New parametric type. I click on reel. Reel. Here it is, reel. At this point, you can input the number of teeth. Assume the number of the teeth is 25, capital N, and put the value here, 25. This is one parameter, and click on new parameter to do another parameter which is related with length. Click on length, find here, and sorry, I didn't use a mouse, just problem is find the length. Here is length. Length means the parameters that I put now is related with the length of the dimensions. And click on new parameter. Click here, length. Let module of the gear is symbolized by small m, and let's take it as 3.5. And another parameter is also length related. Length related, which is the pitch circle radius. The pitch circle radius. This parameter means, let I show you what is parameter. This is a gear parameter or spur gear parameters. Look, addendum circle, pitch circle, and this is a dedendum circle, and there's a face width, and so on. These are the parameter to draw perfect design on software. So another related with length is pitch circle radius. Click here, RP, just capital R and small p, and put the dimension here. And which is denoted by the formula, and click add formula and write the formula for the pitch circle radius, which is available on the textbook of machine element on Shigley. So radius of the pitch circle radius is equal to module times number of teeth divided by 2. This is a formula for module, and the unit is in millimeter. To do that, just multiply by 1 millimeter. ዩኒታችሁን ሚሊሜትር መምጣት ስላለበት በ1 ሚሊሜትር አባዙ ዳይሜንሽኑ ያው ራሱ ነው የሚሆነው። ዘን ክሊክ ኦኬ። እዚህ በዳይሜንሽን ተሳስተሃል ነው የሚለው። The international system unit will be the default, and to do that my real parameters times 1 millimeter. 0.44 millimeter. I have to change this. I have to correct that formula. Circle radius, let's use module times number of teeth divided by 2. Yes, it's correct. 43.75. This is the radius of the pitch in millimeter. And the formula is here, module times n over 2. The other length parameter is, click on new parameter, new part type, and base circle radius, which is denoted by RB, small b. And this is also expressed by the formula, which is 0.94 times RP, P circle radius, capital R, P. Okay, the value is here, automatically calculated. And the other parameter is, click on new part and change this RA, addendum circle radius, capital R, and the value is by formula, generated by formulas. The formula for addendum circle is P circle radius, RP, times plus module M, small m. Click on OK, and the value is automatically calculated here. And the last parameter is dedendum circle radius, which is denoted by RD. Click on new part first, click here, capital R, D, small d, and add formula for this, which is the P circle diameter, or the P circle radius, RP minus 1.25 times module. Okay, which is also automatically calculated. Now I finished all parameters. Now go back to the workbench. Apply, click on apply. Don't forget to click on apply. Then OK. This parameter is applied to the workbench of the CATIA. Now click on or select an axis. Click sketch. Then draw circles. Two circles first. This is the P circle radius, and this one is the P circle radius. So measure it dimension for this dimension. Or the parameter is already loaded or inside the workbench. Click here and generate the given parameter. Right click here and edit formula. Now click on RA or RP, the base circle radius. From here select RP, then OK, which is 41.125. 41.125. Right here, 41.125. If it is not automatically generated here, you can write the values here and OK. And the value of this is RP circle radius. Click on here and right click here and edit formula and click on RP circle radius. RP. Click here. Look, the value here is the value 43.75. If I click OK, it must be generated here. If not, you can write manually this value 43.75. Here, look, I have to write this 43.75. This is the dimension for the base circle radius and the P circle radius. Now what I'm going to do is just select this projection line or an axis and start from the origin, draw some axis and draw some axis like this and measure this, which is a pressure angle, which may be given force per gear. Most of the time the pressure angle force per gear is 20 degree. Now the value is just must be 20 degree force per gear. So click OK. You can move it anywhere like this. And now write draw a vertical line and measure this angle. Between this angle, the vertical line and this line, measure it. which have a formula. This is the formula that I show you on the PDF PowerPoint. This angle means the vertical line, and this line is, look, this is from the vertical axis, from this axis or this angle, from the vertical to this projection line is 360 over 44 times of number of these. That means 360 divided by 4 is 90, 90 over m. Formula for that angle is 90 over m. So I have to write the formulas. Double click on the measurement dimension and you click on an edit formula. Then I can write the formula, which means 90 divided by number of t's, capital N, times, if the unit is degree, I have to multiply by 1 degree, 1 degree, DEG, just you don't miss the spelling and so and so. Click OK, which is automatically calculated, which is 3.6 degree. Then OK. Now what I'm going to do is just draw a circle by centering this line. Let's maximize. Just take the center, this. Take this as a center. And end up the circle at this point. Look, when touching this point. Let me minimize. Now it's perfect. Click it. Now I'm going to remove these two lines. Click this. Two circles are now not needed, so I can just a hidden line, or I can hide it, hide show. Hide show. Before that, let's say Control Z. Just one thing. Okay, just hide show this, hide this two line. Just hide. Click on the line and hide show. Now I have to draw the two another circles, which is addendum and dedendum circles. Draw a circle for addendum and dedendum. This must not be projectilized, this must be solid. This is for addendum and this is for dedendum. Just dimension it. Just make a dimension. Double click here. This is dedendum or RD. So generate the parameter. Right click here. Edit formula, and RD is, click on RD because this is a dedendum radius, which is 39.375. to write this 39.375. now click OK. And for this, for the addendum circle, right click, edit formula, and click on RA, radius of addendum, which is 47.25. 47.25. 47.25. እነዚህ ናቸው። ናው unnecessary የሆኑ ላይኖችን እናጠፋለን ማለት ነው። ቱዝ ፕሮፋይሉን ብቻ ነው የምፈልገው። to do that, this is ላጲስ ምልክት ያለ click on trim ላይ double click አድርጉ and click unnecessary lines here. Trim this also. Just maximize a little bit, and I can move this and click this part. Look, yes. What I need is the profile, the teeth profile. And now I have to add the fillet radius. Click on the fillet here. First, close this. This is the corner or the fillet radius. Click on this profile and click on this line. There is a fillet radius. The fillet radius also have a formula, so I have to put the formula. Double click on the dimension and right click here and edit the formula. Fillet radius from the textbook is given by 0.39 times module. 0.39 times module M. Okay. Yes, it is automatically calculated. Okay. The other unnecessary line here is click on trim. This line is not needed, and these parts also. And click on this part. Now I have a half of the profile for the teeth. So to get the full, I have to mirror this profile. Mirror it. First, close up the trim. Click on this. Press Control and click on this. Click the fillet also. And now click on mirror. Mirror command. Then click on the vertical axis here. Then this is automatically mirror. Now this part and this part should be connected. To do that, click on this point and press Control button and click on this point, and now click here with constraint define. Click on this, and this should be coincidence. Select coincidence, then OK. It's joined together. Now I have the tooth profile of the gear. Then I can draw the 3D part, which is 20 millimeter. This means I can make this divide into 10 millimeter, and I can mirror extend like this. Preview, then OK. Exactly, I get this. Now the number of teeth is 25. So to do that, to draw the number of teeth, just what I'm going to do is click on here, the tree, click on sketch, right click on sketch, and hide show. Click on hide show. Look, I get these white lines. Now select this tooth profile, the white part, including the fleet. Press right control. Okay. Now what I'm going to do is just click on here on the row and circular pattern. Click on circular pattern. Just click on this. Now here on the parameters here generated, right click here and complete crown. Select complete crown, and instance is the number of teeth. Right click here, and the number of teeth is in edit formula, and call up the number of teeth here. Click on N. Click on N. Then OK. And automatically it must be generated automatically. PC setting ማስተካከል ይኖርብኛል። እናንተ ጋር ግን ሊመጣ ይችላል። 25 number of teeth. Now select an axis here, reference element. Right click here on this box, and our reference element must be x-axis. This is automatically generated. Now preview. Then OK. It needs some time. Okay. Look, it is automatic. The perfect gear is generated by this software. The last thing is what I'm doing is just draw the diameter or the hole for the shaft. Just select this and click on sketch and click on circle. The hole. I have to make the hole for the shaft. You can measure it. Assume the diameter of the radius is maybe 10 millimeter. Okay. Then I can pocket. Exit. Click on pocket. This must be 20 because the phase width for the gear is 20. Back 20. Okay. ይቅርታ ትንሽ ሳይጨልም አይቀርም መብራት ጠፍቶ ነው። ይሄ ነው። ሌላው ምንድነው የቀረው? keyway. You have to draw the keyway because the shaft and the gear should be rotated together. The relative motion between the shaft and the gear is kept by a key, so I have to draw a keyway and sketch keyway, exit, now pocket, click OK. The keyway. This is the final design of this part. And then for today it is enough, and for the next tutorial I have to find or draw a pinion gear, and I have to show you how to assemble the pinion and the gear, and how to simulate or how to animate this gear. Thank you for watching. Thank you very much, and don't forget to subscribe.